do we find the zeros of a polynomial that is not factored for us? Because pretty much up until this point, they've been nice and factored, or we've used the graphing calculator to help us. But today we're going to remind ourselves of how we can find a list of possible zeros and then check those zeros to see what works. So this is like the fun stuff where one problem can take you like, I don't know, a lot to do. But if your polynomial has integer coefficients, then every rational zero will be in the form of p over q, where p is a factor of the constant term, and q is the factor of the leading coefficients. And we call those PRZs, possible rational zeros. And I really think once you write it down and you do one, you're going to say, oh, yeah, I remember that. Maybe you'll say that. I feel like I expect you to, well, I expect that you remember way more than you remember. So that's a very safe thing. We're going to watch this fourth football game in a row this weekend. Tournament's coming up. I feel like we're not going to go very far. Not that worried about it. I kind of hoping we don't go very far. 5. He'll be 6 in November. He plays tackle football. Don't you think that's crazy that they play tackle football? But they play tackle football. I feel like they should do flag football first, but they don't. They just put pads on them and just. No. Well, they not here. Like we do it at South for the South Putnam youth football thing, and it's all tackle. Like there's a 4-year-old on our team. Plays tackle football, and Parker totally ran with someone, tackled him right with his helmet at practice, and my husband's like, "Are you okay? I thought that would hurt your head." He's like, "It does," and he's like, "Where does it hurt?" And he said, "Everywhere." So they had to practice tackling, like not leading with your helmet, because I'm like, you're gonna get a concussion, ruin your brain. So way to practice that. It's really funny. Like I know, like we gotta get that. We gotta keep that brain working so we can do some math someday. But I don't know. Parker helped me grade papers this weekend, so he like wrote the numbers. Like I would tell him, I'm like 17 out of 24, so he would write it on there. So if you get some papers back with some messy handwriting, it's not me actually. We call these PRZs possible rational zeros. They're not necessarily the rational zeros, but they're possible ones. And we take the factors of the constant, which would be the one without an x, divided by factors of the leading coefficient. And part of your homework today, you just have to list the possible rational zeros. You don't actually have to find them, so that's super great. And I think on your test there might even be a question like that. That you just take a list of possible rational zeros. So you just got to know factors of the constant over factors of the leading coefficient. We had extra A's, right? Yeah. Well, it's just they're just lots of problems. There's not much. I mean, okay, there's kind of some stuff, right? All right, everybody, do a problem. Don't you feel like you learn more when you write? Like I feel like I learn more when I write my notes. Someone just prints them off for me. I don't like them. I think so. I think it's true. Like if you hear someone say something, then you remember like 50% of it. But if you write it down, you remember like 80%. And if you teach it to someone else, you remember like 100% of it. I'm really making those percentages up, but it's something like that. But I'm not a person that learns from hearing. Like I have to write to do it. Like my teacher in high school read us a book in English, and I had no clue what it was about. Like no idea what it was about because she just read to us and we couldn't see the words, and like I needed to see the words to do it. And it was all about like during World War II, and this Japanese family got put into this little camp, and like I never knew it. And then in college, I learned that in World War II, like we put Japanese Americans in camps. And I was like, how come I never learned this in high school? And one of my friends said, remember that book that she read to us? That was about that. I said, oh, I need to learn it. I need to see it. So that's why I make you write. But some people learn from listening, so you know, maybe I should print your notes out. The these are directions from your homework. It's up to you if you want to write them all down. But it says, use PRZs, possible rational zeros, to write a list of potential rational zeros. Then determine which ones, if any, are zeros. Notice that the directions do not say find all the zeros. They just want you to find the rational zeros. So it's really important that we pay attention to the directions as we're doing this, because later it will say find all the zeros. Back in Algebra 2, before we taught you PRZs, we just would give you a problem like this and say, hey, find the zeros. And you just had to start checking every number, right? And you would check 1 and see if it works, and check 2 and see if it works, and check 3 and see if it works. And we gave you problems that were small enough numbers that you could actually find them. And then we said, hey, wait, there's a way to get a list of them. And every time if you have a polynomial, to get a list of possible rational zeros, I'm going to write it out this time since our notes, we're going to take factors of the constant. So we're going to take factors of negative 14 and divide it by factors of the leading coefficient, which in this case happens to be 3. So what are the factors of negative 14? What multiplies to give you negative 14? 1 and 14? 7 and 2. And remember that your signs can change. Like you could use positive 1 times negative 14, or it could be negative 1 times positive 14. So we always just do plus or minus, right? So we could say like plus or minus 1. I like to go in order from smallest to biggest. So then I'm going to say plus or minus 2, plus or minus 7, plus or minus 14. Those are all the things that multiply out to give you 14. Negative 14. You have vague memories of this? It's coming back to you. And then it's really nice when the leading coefficient is 1, because that means you don't need fractions. But this one has a leading coefficient of 3, so not so bad. It's just prime number, so multiplies 1 and 3. You agree with me on that? Well, we're going to write out our whole list of zeros, and I think you need to put plus or minus for all of them. Mr. McClure not make you do such things. What am I going to do with that, man? I think you got to write. If you want to write just plus or minus once up here, but when you actually list them all, I think you should say every one of them is plus or minus. And remember, you just have to go through and make all your combinations. So everything could be over 1, which you agree would be plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. 1 over 1, 2 over 1, 7 over 1, 14 over 1. But then I have to also put all these over 3, because remember, rational numbers are also fractions. So those are the ones that we always wait till the end to check, because nobody wants to check fraction. But that would be plus or minus 1/3, plus or minus 2/3, plus or minus 7/3, or plus or minus 14/3. And then it says, determine which ones, if any, are actual zeros. Which means, how do you know if this number works as a zero into this problem? What? Plug it in and see if you get what? 0. Which means, on a test, I'm not going to give you one that has this many options, because that could take you the whole hour just to do that. But you have to plug these numbers in and see which ones give you 0. And so you could actually divide them out, like synthetically divide it out, but that's where the remainder theorem is really nice, because I can say, I know if I plug 1 in here, if I get 0 out of it, then I know it's a 0, and then I can go from there. So I just have to plug it in, and that's where you can use your calculator. For small numbers, I just say, let's see what happens. 3 minus 7 plus 6 minus 14. I just always look to see if like the positive and the negatives cancel out, and I don't think that's going to work, right? 9, no, that's not going to work. Not 1. So then I take negative 1. Who's having fun yet? Then I plug in negative 1, and I get That's not good, huh? When I plug a negative number in there, is that going to happen every time? Is it going to turn every number negative? I mean, is it going to... You see how these are all negative, 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 negative? When I plug a negative number into this, is it always going to make it negative? Is it always going to keep this negative? Is it always going to make this negative? Which means, do I need to check any more negative numbers? You follow me on that? So, like, if you notice that it's just going to keep getting smaller or keep getting bigger, so, like, for me, I was like, well, this isn't going to work, and neither is any other negative number, which means I've just eliminated half my choices. That's good, right? So then I check 2, I plug 2 in here. You got to do this on your homework, kids. And I got lazy at this point. I just used my calculator, and I just typed it on my calculator, and I wrote, I got -6. I don't know if that's true or not, but that's what I have on my paper. And then I got discouraged, so I started jumping around, hoping I could find the right answer. So then I jumped to 7, and I said, what happens when I plug 7 in there? And guess what I got? 714. That wasn't good. Then I plugged in 14. I guess I didn't jump around that much. But notice I'm avoiding the fractions, and I got 6,930. Which means I had to go to the fractions. And this is where you want to be proficient in using your fraction button so that you don't have to do all this work by hand. If you're not proficient in using your fraction button with exponents, please see me. But like if I plugged in, let's just jump ahead to 7/3. You have a calculator and you want to check to make sure you know how to do this. Be happy to grab one or plug this in. If you plug 7/3 in there, if you use a fraction button, I don't know, I just always use parentheses. So like if I was doing this, I would do 3 parentheses 7/3 parentheses cubed, which I would probably do caret, and then 3 minus 7 parentheses 7/3 parentheses squared. Make sure you use parentheses. Plus 6 times 7/3 minus 14. And guess what? When I did that one, I got 0. So here's where you have options, okay? One option is, have we checked every PRZ to know for sure if they all work or don't work? Which means your one option is, you have to keep checking, because it says find all possible rational zeros. Which means I've checked most of them, but I have a few more fractions to check. I don't need to check the negative ones, because I know they're not going to work. But you have to check them all if you don't want to do the other option. The other option is, once you find one that works, we can divide out that 0 and use what's left to factor it. And I think that's a good option because we have to do that eventually anyway. So here's my suggestion. This is what I'm going to do. So since this works, we know that we have 1 0 at x equals 7/3. Let's divide that out and see what's left. Because what's left, maybe we could factor to find the other zeros. Or if it's not factorable, it's not rational, so we don't have to go. So let's, I'm going to write out some directions here. Divide out the 0. So I'm going to divide out 7/3, and I'm a synthetic division kind of person, so I'm going to always do synthetic division. And that original problem, I'm going to bring down my coefficient. So I had a 3, a -7, a 6, and a -14. And you might be freaking out a little bit because there's a fraction here. But it actually is going to work out really nice because we already know that the remainder is 0, and it's going to work out. So if I bring my 3 down here, if you take 3 times 7/3, do you agree the 3's cancel each other out? 7/3 times 3, the 3's go away, so that's just 7. And then -7 plus 7 is 0. And what's 0 times 7/3? 0. 6 plus 0 is 6. What would 6 times 7/3 be? We cancel out the 3 with the 6 and make that a 2 times 7. It's 14. And that better give me 0. Since I plugged in, I got 0. And then write what's left. If the original one was x to the third, how do I write what's left here? I'm going to write it up here. 3x squared, this would be plus 0x, so I'm not going to put that, plus 6. Now see if you can solve that, and if you get a nice rational number, then it's your other PRZs. For now, since it says just find rational zeros, if it's not rational, then we don't care about it. So like if I solve this, set it equal to 0, I would get 3x squared equals negative 6, x squared equals negative 2. Is that going to work out to be a nice number? That's going to be an imaginary number, which means it's not rational, so I don't care about this. So I'm just going to put not rational, so you have that in your notes. If this was on my paper, I would just kind of like put an X through it, because I don't need to solve it. I think that's better than checking them all. I hate checking them all. It annoys me. So, and this helps us when we get to the part that says find all the zeros. So I say find 1 0, divide it out. But I'm not going to lie. There's some on your homework. You're going to have to just check. You better hope they're odd so you can just cheat and you know which one, and just happen to check that one first, right? Oh, I just happened to check 1/5 first. It was my first guess. I'm so lucky. So let's try this one. List your PRZs. And this is where, once you know, you don't have to write factors of 9 over factors of 2. You can, but usually I just write the factors of 9 on top and the factors of 2 on the bottom, which is always nice when there's not a million to do. 9 would just be what? Plus or minus 1, plus or minus 3, plus or minus 9. And then factors of 2 on the bottom, plus or minus 1, plus or minus 2. And then I do actually want you to write it out. When it says list the possible rational zeros, don't leave it like this. Like, actually work it out. And we would have plus or minus 1, plus or minus 3, plus or minus 9. Sometimes you get the same one again. It's not happening on this. But let's say, like, you had 3, and then you had 9 over 3, which is 3 again when you divide it out. You don't have to write it more than once. You only have to check it once. Then we do have these fractions here, plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. 12 different ones to check, which means on directions like this, if you just wanted to check all 12 and not ever do synthetic division and just give me the ones that work, like that definitely works. I'm just not a fan of doing it. So, I feel like I should make you do this, because I feel like you don't realize what you're doing on this if I just give you the answer. I like to show you all the work that I did so that you see that I don't just magically know the answer either. I always hope that 1 or negative 1 works, because I don't need a calculator for that. When it works, it makes me so happy. But I don't think this works. 2 minus 1 minus 9 plus 9. So close. It's 1. No, it's 0. And then I check negative 1. And I got negative 2 minus 1 plus 9 plus 9. That didn't work either. And then I use my calculator, because after that I don't want to do all that by hand. And I jumped all around. Actually, I really didn't. I pretend I jumped around, but I really don't. I went right in order. I checked 9. Guess what? I got 1305. So I guess I skipped 3. I jumped to 9. And then I checked negative 9. And I got negative 45. Then I checked 1/2, because I was like, alright, it's going to be a fraction. And I got 4.5. So just so you know, I checked all these too. So I like to tell you this so that you don't get, hopefully, super frustrated, because obviously it took me a lot longer to actually get these answers than what I'm giving them to you right now. But I just like to show you this, that I don't know which one to take right away either. I got 4. Then I checked 9 halves, and I got 130 and a half. At this point, I've checked quite a few of these, right? Which means if you find one that actually works, you might just check the few that you haven't checked and save yourself some time, because look how many I've checked here. I checked negative 9 halves, and I got 1. Which means, what do I have left? 3 and 3 halves? It's the only ones I have left. So I checked 3 halves next, and finally I got 0. So that's what I mean about the odd problems when you happen to guess it right. It's kind of nice.
So only 1 to get 0?
Well, there could be more than one that works, right? And that's what we did last time. So that's why I said now you have 2 options. One option is we only have 3 more to check. Negative 3 halves, 3 and negative 3. They could work, and so you want to check them all. The other option would be to divide it out and see if what's left is factorable. You see what I'm saying?
Okay.
Because technically speaking, we haven't talked about this yet, but a degree 3 function could have up to 3 zeros. Have we talked about that? Like the most zeros it could have would be the degree of it. So there could be 2 more that work, but there's a good chance that there's not. So you have to check them. So since this one there's only 3 more to check, like we could check negative 3 halves, we could check 3, and we could check negative 3. And if those 3 don't work, then we're done. If you are doing an odd problem and you happen to just check 3 halves first, the smart thing would be to do what we did on the last one. Divide it out, see what's left, and see if you could solve it. Does that make sense? If we did. On this one, these don't work either, so I don't know what they are, but they don't work. I'm just going to put X by them. Which means this is the other way you could do these problems. Just check all 12 numbers. How fun is that? Not very fun. That's why on your test, I don't give you ones that have a million to check. So the answer to this is which zeros actually work. The only one on this one would be 3 halves. Okay, I got one more thing, and it is a little bit of writing, and then we're going to stop. We're going to cut the homework off today since we have extra day, and we'll do the rest of it tomorrow. No, just less homework. Okay, I'll just change the homework to just ones you can do today. Does that make sense? But we got to write first. Upper and lower bound rules. So I'll just be quiet for a minute, and I'll check out the homework and see what we do. Why you guys write a little bit. And then tomorrow we'll do all the zeros. I really only have 2 more questions after this, but I feel like we're going to be short. This is something that you don't talk about in Algebra 2, upper and lower bounds, and it's just supposed to be another way to help when you're checking zeros. I don't find that it helps me that much, but I puts it in there. There's a couple homework questions, so I want to make sure I show it to you. Notice I tried to shorten it up as much as I could as I was typing. So notice the beginning part is just the rules for this rule. In order to use this rule, you have to have a function with real coefficients and a positive leading coefficient. So if the leading coefficient isn't positive, this doesn't work. And if you divide it by some thing that's not at 0, but by some x minus c, if what you're dividing by, c, is bigger than 0, so if you're dividing by a positive number, and each number in the last row of synthetic division, that means like when you get your answer, is either positive or 0, because 0 counts both, then we say that that there are no zeros bigger than C. And what that's supposed to do is if you check that, then and you see it's an upper bound, you don't have to check anything bigger than that. The problem that I see with it is we don't usually check our zeros doing synthetic division. We usually check them using the remainder theorem, so it doesn't come into play very often for us. But it is on the homework, like it says, check to see whether you have an upper or a lower bound. So which means there's a number 2 here. If what you're dividing by is less than 0, so if you divide by a negative number, and what you get when you synthetically divide alternates from positive to negative, like it goes positive, negative, positive, negative, or negative, positive, negative, positive, then that is a lower bound. I don't know why I made that one uppercase and this one's not. The lower bound for the zeros, which means no 0 is smaller than C. And really, these aren't that bad of problems as long as you know what I'm talking about here when we do it. So I have an example or two here, and then we'll be done. You don't have much homework today, and I've cut it down, so 1, 2, 3, 4, 5, 6, 7. You only have 8 problems anyway, so I have less than 8 problems. Ridiculous. Right.
So scared to wake up and everything.
Yeah, maybe you shouldn't sit in class if you there's one lesson to learn.
Yeah, I don't know why. Oh.
It's 2 more minutes, we can be done right this second. You can do all but 2 problems on homework. What do you think about that? 3 problems on homework. No, 2 problems on homework. So that means only 2 problems homework tomorrow, though, right? Think about that. 6 today, 2 tomorrow. Second hour is got to do them all at once. That's what they get for having conversations. Images. Someone watches this, you think they just, like, skip ahead. That's the good thing about watching it again. You can just skip this pausing time. Because if you're just watching it, you just print the notes out and you don't have to write it. That's what Bryce does at home, right? When you have to do sleeping class, you just go home and watch the video. Ridiculous, Bryce. I'm going to not allow you to watch it anymore. Alright, let's try one. You don't, like, you could just put, like, here's a shortened version of the directions. Show K is upper or lower bound. Right, write that instead of that. But the directions on your homework say use synthetic division to prove that the number K is an upper or lower bound for the real zeros of the function. The nice thing is the rules say if K is positive, the only option is it to be an upper bound. If K is negative, the only option is it for it to be a lower bound. So when I see that K equals 5, I know that it better be an upper bound if it's anything. And that means that when I synthetically divide, the numbers that I get on the bottom should all be positive. So I'm just going to divide this. I'm going to have possible zero, right? I'm not looking that 5 is a zero of it. I'm looking that it's an upper bound. So if I do that, 2 times 5 is 10. When I add that together, I get 5. 5 times 5 is 25. When I add that together, I get 20. 20 times 5 is 100. When I add that together, I get 99. So I get that all of those are positive, which means I can say 5 is an upper bound. Which means that there are no zeros bigger than 5. I find that to be a little ridiculous because using what we know about PRZs, are there any PRZs even bigger than 5? Factors of 1 over factors of 2. You see how that's annoying? I find that to be annoying. It doesn't help me to know that 5 is an upper bound because obviously 5 is an upper bound. I could have told you that based on the PRZs, but that's just me being annoyed. All right, one more. Just to show you. If it's negative, then the only option is for it to be a lower bound. And if it's a lower bound, your last numbers on your synthetic division better alternate. Positive, negative, positive, negative. Or negative, positive, negative, positive. If it skips an exponent, you still got to fill your 0 in. I'm just going to bring down 3, negative 4, 1, 3, and now I'm dividing by negative 1. If it doesn't work, like right away, like if the next number is positive, I could tell you negative 1 is not a lower bound because it has to alternate. But 3 times negative 1 is negative 3, so I get negative 7. Negative 7 times negative 1 is 7, so that would be 8. And 8 times negative 1 is negative 8, and I would have a remainder of negative 5. Because it alternates, I could say that negative 1 is a lower bound. That is helpful on this one because there are possible zeros that are less than negative 1. Like negative 3 is a possible zero that I wouldn't have to check if I knew that negative 1 is a lower bound. All right, so there's a couple questions on your homework just like that that aren't so bad to do. The ones that make you check the PRZs, those are kind of not so great to do. All right, so your homework, and we're still going to do all of this. We're just going to wait and do these other two tomorrow. I think you can do everything but 51 and 54. Yeah. So 33, 36, 39, 42, 47, and 57. 33 and 36 are where you have to tell me which ones work. Those are going to take the most time. 39 and 42 are the upper and lower bounds, which aren't so bad to do. And 47 is the upper and lower bound, and we'll probably talk about that because it gives you a graph. And then 57 is a little story problem. So the only ones we're not doing yet are 51 and 54. So we can finish those tomorrow. Maybe I can turn back some homework quizzes and stuff for tomorrow as well if I can grade the same. So get started on this so that way like 33 is